Pues buenas tardes de nuevo a todas y a todos. Hoy llegamos a la última sesión, la última charla de esta cátedra internacional de ingeniería. A mí me está dando ya pena despedirnos, ¿no? Después de 2 semanas viéndonos todas las tardes y leyendo todas las tardes, pues ya da pena, pero pues espero que la hayáis disfrutado. Como última conferencista, tenemos el honor de presentar a una egresada de la Universidad Nacional de Colombia, en concreto de la Facultad de Ingeniería Civil, la profesora Jacqueline Vera, que es profesora de Ingeniería Civil en la Universidad de Calgary, en Alberta, Canadá. Profe, ya no voy a decir más sobre usted, ya se encarga de la presentación, le cedo la palabra. Muchas, muchas, muchas gracias por aceptar nuestra invitación, por estar hoy presente y por compartirnos un ratito de su tiempo y de su conocimiento. Muchas, muchas gracias.
Mira, estoy agradecida por la invitación, pero estoy más feliz de saber que voy a hablar a los estudiantes de la Universidad Nacional hoy. Part of the presentation is going to be in English, definitely. And let me start with this one. So just want to make sure that you can see my screen.
Yes, we can. Lo podemos ver.
Okay. Bueno, so as Teresa was saying, well, what can I say? Thank you for taking your time on Friday afternoon to come and listen to a presentation about empower students as leaders of their learning, to lead creativity, innovation, and entrepreneurship. Definitely, I appreciate that you're taking the time to come and listen, but also I'm looking for your participation. Teresa, this is one of the things I was saying at the beginning. I would like to check who is online, and more important to say yes and no. What kind of learning style you're experiencing daily? I want you to reflect and think if you are one of those students who come to lecture. Now you like to see the pre-recorded lectures, is better for you. You like to take notes, prefer to work individually, and maybe like to write individual exams. So you take a moment and let us know yes or no. I would say first, say yes, the ones who identify with this group. And we're gonna do a little bit of counting and see at the end where it will lead us. Teresa, can we count a little bit so we know plus minus how many people is saying yes? You are the ones who prefer.
Sí, ahora le digo, profe, lo que pasa que como con la visualización de YouTube va con retraso, entonces dejémosle un minuto a los chicos para que escuchen esto y ya empiecen a responder.
Okay. So I want them to basically self-reflect. What is my learning style? Do I want to come to class? Do I want to go and see the professor in front? I wanted to bring my computer. In the meantime, I wanted to listen, maybe take notes, or maybe I just watching the pre-record lessons now. And the most important I want you to reflect is if you like to write individually rather than teamwork. Because you count a little bit of the technology.
Ya se está reproduciendo la pregunta. Ahora ya vamos a empezar a recibir respuestas. Ahora le digo las respuestas, profe.
Está bien. So one thing that actually is giving the students the possibility to reflect, because it's one of the conditions that we want out of this presentation. So had you ever take the time to say, think about it. Do you like to come? You are more shy. You prefer to just do whatever it says, read the course online, complete the assignments, or
Parece que los estudiantes no quieren participar. ¿Cómo que no? ¿Qué prefieren? Ir a las clases, prefieren una clase pregrabada, prefieren tomar notas, prefieren trabajar de manera individual. o prefieren escribir exámenes individuales.
So if they are not answering quite quickly, so you can see that most of the people is kind of sort of shy. That has been an indication for some of the lectures right now. And maybe individual work has been a challenge.
Por
So,
aquí en privado me dicen, profe, que ellos prefieren trabajar de manera individual, tomar notas.
sí.
Esas
So
son
the way,
algunas respuestas.
so if we don't get immediate response sometimes with that one, it's an indication that the majority of people like
Yeah. Someone prefers to work individually because I'm so shy. David Marulanda says, take notes.
take notes. There you go.
Yeah.
So if someone could
take
answer,
notes, pre-record. sorry, profe.
no, we just
They are starting to answer.
just start thinking about introduction, because it means that many of us, and actually I used to be one of those who prefer to come and, you know, the last they ask me, I just gonna do my exam and my assignment. And the next question then for some other is, do you prefer to the opposite, interact, maybe talk to people, go to party, of course, but probably in terms of work, do you perform better in a group environment? And you like to do things with your hands. So what would you say is hands-on skills is best? So think about it. If you're one of those, it would be nice to have a sense if we have some people in the audience today. So Teresa, how many people are we supposed to expecting today? Okay.
Around 100 people, 120 around, but they are starting to connect now. We have around 60 people by now.
So out of those, it would be nice to have a sense, because in so many demonstrations that we have done, so the division of this group of people is getting wider and wider. So we're gonna say that 40% right now is getting into the individual basis, and 60% is moving into the group-based work. But that is not the way that we are teaching, right? So actually, when you have these two groups of people, as a professors, as a communities in university, the biggest question is, what is the best way to teach these students? So the ones who prefer just come, present, pass, get an A, or the ones who come, interact, get it wrong, and maybe pass, right? So one of the things I want you to start and finish the part of the presentation is that as a professor and as an engineer, I found that the point is not to teach each student in the way that he or she prefers. Rather is to make the instructions to balance, no heavily biased in favor to one preference or opposite. So sounds easy, but it's really difficult when we are designing courses. So one of the things that when we professors design courses need to think is about engagement. So we want people to get interested in our subjects. We want them to be engaged into the curriculum, and in the end, engaged and happy with the outcome of the courses. But lately, one of the other strategies is how we empower these students to use the skills that are practical, that they find inciting and is relevant to what they're going to be doing in the future, and more important, to identify opportunities to practice their ideas and had a vision to implement, improve, or change. Now, for that reason, I just want to start with my own experience. Designing a course had taken a transition from the typical normal class for shy students to a different level. So I'm going to start by saying that many, many, many years ago, in a beautiful place in South America, was a student, shy, who likes to take notes, work individually, and present exams. I was lucky enough to came across with a professor who has a critical thinking and innovating ideas, who open opportunities for the student to work with material that at the time, so I'm telling you that is more than 20 something years now, has the opportunity to work with materials that were not very common in the city, and give the opportunity to work with one of the professors in structural steel at the time closely. After that, she was pushed to pursue higher studies and ended up working with one of the highly recognized professors in Colombia, Dr. Uribe. Now, when you go to the university and you wanted to go out and perform, I took out of that experience one difficult word to define, that is inspiration. And probably the best way I wanted to express this one is by many years ago, I attended a conference by Dr. Sir Riverson, and he started talking about inspiration with the following story. He says that it was at the time a little girl who was 6 years old sitting in a drawing lesson. Okay, think about the little girl that is drawing. The teacher was complaining about that the girl hardly ever paid attention to class. So the teacher, excited, went over the girl and asked, "What are you drawing?" The girl says, "A picture of God." The teacher said, "But nobody knows what God looks like." The girl says, "They will in a minute." So the inspiration will come with an inside feeling that don't be afraid to be wrong. So if you find people at the university that inspire you to go and try new ideas, not to be afraid to be wrong, and try to innovate. Now, what is being said, the studies shows, is that don't be afraid to be wrong is a characteristic of kids between age 3 to 12, and over time get lost when we have exams, when we have proof that you do over time wrong and so on. But one thing I can tell you though, is that what we do know is that if you are not prepared to be wrong, you will never come up with anything original. And we have research data with that. Now, after so many years, I had the opportunity to move out of the country, and I found a job. And I found a job in a small company working as an engineering training. And the people that I have to interact were from different parts of the world, specifically Scotland. They were different. So they will push you to work with a new term that for me was difficult to understand: diversity, inclusion, gender. So we're talking about more than 20 years ago now, where we were talking about equality, where we're talking about without excluding conditions. When we were working with English, Spanish, Scotland, all those conditions were new. So I had to open myself to the diversity. I have to share a passion for teaching. And even though in this new country, I took the option not to be wrong and apply for a position on a college that said as an instructor or professor in the School of Construction for the civil engineering program. There, I was accepted, and bringing the experience and the inspiration that I have from the university, combining with the diversity was exposed, and all the projects that I have worked so far, I developed structural classes with active learning components. That started in 2002. Well, I started working there in 2000, but implementing those ideas were in 2002. I was pushing students to think out of the boundaries, to push themselves to interact as a team, to present their work, and in the end, most of the time, the common comment was, "This is not a common practice for an engineering class, so must be wrong." At some point, well, do you hesitate? Yeah, well, I had the inspiration. I was not afraid to be wrong in this approach. Being in this approach, I wrote a letter to the Canadian Society of Civil Engineers in 2009, and I request participation of undergrad students into a building competition, popsicles bridge competition, that at the time was exclusively for engineers. And I have to show this one because that year the students won the competition. So maybe the approach was not that wrong. maybe the students had the opportunity to practice and get around ideas. So please notice that we are trying to build the concepts on how the new engineering design courses are coming to light, and more into these times like a COVID time. I wanted to show some of the experiences that we have in 2006, where being instructor, I have the opportunity to be involved in the concept design for the one of the largest, or I would say the second largest office building in Canada and in the western side. Please notice that right now the building has 59 stories, has a die-grid condition. And one of the things I will say that I learned from here is that when you are invited to work in a concept design, you need to start listening all kind of people: architects, vendors, contractors, designers, different conditions. And one of the ones I want to share here is that the initial number of stories for the building were 72. 72. Jacqueline, but you said 59. So out of those conversations, one particular group came and changed the entire concept design. They were the environmental and architectural group. They came and told us that the height of the building was projecting a shadow over the river, and the shadow over the river will change the dynamic of the fish life. And then government, investors, and people had to change the design of the building. So we went from 72 to 59. Huge issues into those ones. Now, different configurations, definitely. I had the opportunity to bring students to be part of those conversations, to observe how is the design process, how people participate, how people act, speak, and more important, contribute with ideas of what is needed in the design. We combine technical knowledge, of course, in many different parts of the world, and we had the opportunity to bring students over the job site over 4 years. One comment I have about this particular exercise is that problem-solving skills was a success for this particular problem because students' feedback and engineers' feedback. So we combine expert-novice differences. We were open to listen and create problem solutions. We were able to create a structure for complex solving problems, and we were open to problem-based learning. Always is a learning process. Look, if you Google Bow Building Calgary, you will find that we hold the record to have the largest foundation poured in concrete, 50 megapascals and more, to coordinate more than 500 people over 39.5 hours, and a coordination over 3 months. And that happened when you have problem-solving skills. Yeah? So in the problem-solving skills is something that I took a note when we were designing courses. Okay. Now notice all the conditions and coordinations up to the point that I can tell you that delayed were not part of the project in the foundation process, and it's been one of the most successful construction projects so far in the western of Canada. Now, I took this idea into my classes, and then I started taking students all across Canada. We went to Northwest Territories close to the North Pole. We started interacting with industry partners and so on. That was a success, and that was bringing the students the ability to interact with partners and partner with the industry, get ideas, and actually be active and actually create a networking. Now, in 2009, out of taking students out, I took for 5 weeks a group of students to Singapore. And then we start observing that the only enthusiastic and happy people in those experiences were the instructors. Students were disengaged. People were sleeping. How many of you are doing the same thing during the class these days? or are you playing with the computer or with the cell phone? So it's something that started creating a concern while I was teaching overseas. One of the things I created in 2008 is a Lego Summer Camp. I said, why don't we start training students at a younger age? So I created a summer camp for younger students, grade 9 to 12. They will come to SAIT and we will give some tools in engineering, and we try to engage into work programs. Look, all of that to tell you that yes, I mean, recognized, got so many recognitions. Teaching was professor center. We were doing the best for our students, but still, when I was observing classes, I was observing that the students were not totally engaged. People were not totally happy. So then I said, something is missing. When we went outside, we asked the industry what is needed. They said, we need people with creative thinking, with critical thinking. We want people that is highly and strong self-directed learning. We wanted to create a high communications for all levels, and we wanted to create a supported environment. So that is when I took the chance to go to Shell Canada and be part of Project and Technology Group. So being there, I was faced with one of the tools that is really hard to define, that is communication. What is communication? Write an email, take a phone call to the people, express an idea, and most difficult tool to implement when you want to change something. When you want to change something, but also when you have to interact with people all levels. In this particular case, I'm going to show you is we had people from Europe that did not speak English. Some of them did not speak English. And we need to make sure that whatever they follow the safety rules. So you need to communicate in many different ways. It's not only 3 mails communications, long specifications, and more. So how to create a better way to communicate? Let me show you an example. In 2014, I was challenged to go to one of the mines in production of oil. And the reason for me to go there is that many of these structural conditions that we call walkways were damaged. And what is a walkway? So imagine this bridge, these 2 pipes. We inject oxygen or air in such that we can put them on water, okay, and they float. They're floating, and they allowed the technicians to walk from the shore to the center of the lake in a safely manner, okay? So it moves all the way. So why they got damaged? Well, sometimes for operation conditions, you have to remove the walkways. But think to consider here. Sometimes we can go to temperatures to minus 40 in Calgary, minus 55 in the mine, or plus 40 in the mine, or like this past week or this weekend we've been a plus 30. So notice that when these change conditions in temperature, people will not read the specifications. They will not pay attention how to remove the walkways. And then what happened, they ended up damaging most of the walkways. So they damaged the walkways, and in my case, I have to go and assess what was happening. So I start doing the research. What is the walkway? Who or what are the stakeholders? And please notice the stakeholder is who paid the money, who is the vendor, who does the engineering, who does the project management, what codes and technical standards do we follow? Do we do construction quality? Do we follow those things? And that requires a lot of professional skills, critical thinking. Why? Because in this case, when we estimate the cost, we found that the cost to repair 15 meters okay, will be $60,000. And for the walkway that I was assigned, it will cost $1 million. $1 million to repair a walkway that is not necessarily highly used. So when you start reflecting, you will identify a possibility. When you are designing a course, you have to provide the students the ability to reflect and identify opportunities. So identify this opportunity, and then I start assessing why they're failing, what kind of materials they're using, and then I try to create an opportunity, and we define different procedures, and we execute a totally different project. What is that? So I proposed to change steel material by FRP. Yeah, Dr. Uribe will not be happy with me, sure. But the FRP, what is FRP? Fiber reinforced polymer. It's a material that was offering a new opportunity to use a lighter material, and it gave us the flexibility to design a more flexible movement into the walkways over the water. So why I'm showing this is that we ended up with a design that up to today is being accepted as a Shell oil company requirements to use in any walkway around the world. So what I did at the time is that we proved that by using this walkway, we could reduce $600,000 into this project. Okay, so $600,000, they accepted. Now it's a norm and a specification for Shell. And of course, we got a bonus. Now, I want you to go back and reflect to what we had done so far. We are under training as an engineers or any science discipline that you are in right now. And I'm saying that probably you have to go back to your professors and say, well, what is needed is problem solving skills, definitely. Professional skills, critical thinking. Go back and check what is a critical thinking. Self-directed learning. And everything will be possible, of course, if we add teamwork skills. So the project that I described at Shell was possible because I managed to communicate, but also I managed to work as a team. Being the engineering team lead, I managed to turn groups into high-performance teams. Means that you can make decisions. Means that you can reach out a lot of people and say, hey, this is an idea, this is an opportunity. Means that you can deal with difficulties, and means that you can create a cooperative learning environment. Teamwork, so solving problems, professional skills, teamwork skills. What happened at the time? 5 years ago, they didn't let me off. I decided, and as I said, I have a passion for teaching. I decided to accept a position at the University of Calgary as an instructor. And I decided to join to a team that is forming students from all around the world. And I thought it was easy. Actually, that easy that I never thought that these days the world is only one. Small, by the way. And one big challenge that I have at the time to teach was that most of the courses should cover ideas of discovery, creativity, and innovation. So globalization was a big problem that has to be addressed by engineering courses. In addition, and more important these days, is that we have to help the students to think like an entrepreneur more than ever before. We need to form students with that conditions. Can I do that with the technical courses that I teach? Now, probably one of the most critical ones is that being global, being entrepreneurial, is that most of us, performance and attention is different. The attention will start over a period of time. So actually I've been speaking for how many minutes now? 20 minutes, I guess, or less. So I hope that still I am getting your attention, but I know that at some point we're gonna need a break, then go back and regain and break. So there were so many challenges for us to go into those things. So I said how we can use all of those, collecting concepts, inspiration, diversity, solving problem strategies, critical thinking, self-directed learning, and forming teams and working as a team. What will be the key portion to come into a university and make sure that this is happening? Well, definitely I would say that we flipped the condition. So I have to revisit my teaching style, and I have to think about the learners or the students at this point. I have to consider that the students, aspects of the students' diversity, and I have to consider that the teaching right now has to be inductive and the learning has to be inductive. Very important, inductive teaching and inductive learning. That my teaching strategies have to turn into the learner, not into the professor. What I'm saying that, I used to come to one of my classes, I used to prepare with 2-3 hours in advance. I used to come perform and do a perfect class. Me. Now I have to come and think about learners. Can they repeat that? Can they do that? Now, for people who may get interested into the future, or you will provide feedback to your faculty in the future, you will see what I'm talking about. I will encourage you to go and get the book by Dr. Richard M. Felder. Actually, this book is really good for those who are teaching, for those who are planning to provide feedback to teaching and more. You learn how to provide feedback, you learn how to get that feedback and implement. So one of the suggestions there is that we create courses thinking about the learner in the center. We write objectives and we plan our courses and we plan the sessions thinking about the students being the center. We come and teach with technology, sure. We implement effective instruction conditions, and we evaluate the learning thinking about the students being the center. We provide solving skills, we provide professional skills, we provide teamwork skills, we provide teaching revision conditions every time. How? Thinking about the learning in the center. So all of that to tell you that that is what I used to implement and write a proposal in 2016 to the Faculty of Engineering to create a course, a second year course that is called ENCI 337, and to change some of the changes and implement some of the changes that I'm going to share with you in a few minutes. So don't worry, Teresa, we're going to ask students to participate. And let me start by saying what is 337. So I want you to picture a second year student. So what is a second year student in the National University? It's like third semester in engineering program, right? So we call it Tools for Civil Engineering because we're gonna give them the first taste of how to be working on a group work environment. We're gonna expose the students to a design process. We're gonna ask the students to evaluate themselves, to cooperate. At the same time, we're gonna ask the students to develop the skills that are aimed to develop a final project, like a 3D printer, for example, AutoCAD, modeling 3D. We are gonna expose the students to mental health awareness. We're gonna ask the students to cooperate with others. So how does it work? We create an open-end problem, and we create lectures and sessions that will build the necessary skills for the students to succeed at the end. Give us an example, Jackie. Okay. Example of 2018 questions. We task the students to hold a load with one-end support. And we gave vague information. We gave them materials. We get access to support conditions. This for 2019, actually, instead of one support, we provide two supports. We ask students to think about how to come up with a design when the load is applied in the Moodle. Now, what is it changing then? We're changing the class layout. So I want you to dream that one day you will come to class and you don't see the same layout of the class. Every class, the layout, and what I mean by layout is the distribution of the chairs. We can move tables around. Sometimes you will have whiteboards for each table. Sometimes you work with 2 people, sometimes you work with 4 people, sometimes you work with 10 people. So in other words, we have an open space lecture room, and it's not a typical lecture. Sometimes we bring people to come and talk to you. Sometimes we just come and do activities. The second part is that you can go online and you can watch the pre-record lessons, or you can use what we call lynda.com platform. Actually, you can access the platform. I believe it's not that expensive. It's a really good platform to get all kind of training. So even you wanted, you can go to YouTube and see more about those tools. We will not judge. Is your learning way preference? What you have to come is get prepared to come to the lab and perform during the lab practicum. So we give you in advance the task. You go and prepare yourself with the pre-recorded lessons. You go and read. You have access to teaching assistants. You write an emails. You think about it. You come to the lab and you deliver. You manage to finish the lab means that you really learn, and now you can perform individually. Yeah. So how do you get assessed in this class? Well, there are no exams. So you want to come to this class? I would say most of us, if it's not exam, if it's nothing similar, for sure. So what would be, or how you will be successful in this class if it's not exams? Jacqueline, what is going to happen if I don't like to work in groups? Well, don't worry, you will have a space to perform in an individual basis. But what would you need? Definitely what is being identified. The following items are being identified as a key items performance in this class. You need to develop communication skills. You need to be open-minded. You need to be patient. You need to attend. You need to be creative. You need to use imagination. You have to put effort. You have to create a passion for what you're doing. And the most important for me at some point, you have to work in team environments. Example, one of the conditions that we're doing. One of the first activities that you will come to this class and perform is what we call Lego ice break. This is one of the first activities that group participate, and their role is to identify who has leadership skills, who has technical skills, who has networking skills. So as a first activity, you will see that many things can be withdrawn from this activity. We're going to ask you to do team performance building. Now, in COVID times, we ask students to do different activities, but it's still, I'm not sure how it's in Bogota at the moment, but in Canada, we're allowed to have meetings up to 15 people. So we still manage to have team building activities. Sometimes they can go to the university, sometimes they just go to a house, cook cookies and whatever you have. At the end of the third week, we stop and ask the students, do you understand what you just started? Had you looked wide enough? So basically, we ask them to use this term is think in a divergent manner. So think why. Do you really understand what are the opportunities that you have? Had you looked many possibilities, how you're gonna solve the problem? We give it to you an open end. Do you understand what is asked? Okay. Then we ask the students, if you understand, start using your ideas. How can you perform that? Why? Because you're gonna build it. You're gonna tell us that you are building your skills. Now everyone knows how to draw using AutoCAD, 3D modeling. And because this is a prerequisite, we have as a prerequisite a course that is called statics. You have to prove that you can connect concepts from previous courses to these courses, and then maybe create a technical tool that is called technical assurance. So what is a technical assurance? Somebody will come and demonstrate that they can do the analysis by hand. So for those learners who likes to do individual work, this is a perfect fit. And for those who wants to go and work in group environment, they will do and perform a coefficient matrix and solve forces and compare answers and make sure that whatever you're proposing is correct. Then everyone has to compromise. They will compromise that they will attend classes, that they will be part of the team, that they will communicate, and more. And they create a team, they create a plan, and they start working really hard. Some of the students even create the logo. Some of the students start dreaming about the companies in the future, and so on and so on. Now, the example I'm showing here, of course, is one of the best. I have some of them that are not good, but in general terms, the results last year was pretty good. The students start planning all the ideas. They select the best out of the many, and they get prepared to answer the next 3 questions. Did you select the best option for the group? Do you know how to implement it? Because you're gonna build it. Do you know if it's feasible or not? If the answers are yes, yes, each group is assigned with a 3D printer, and the faculty provides the material. So students start going to the lab, 3D printer lab that we have at the university, and we as instructors left it open for them to use their imagination and overcome problems. So one of the things that students learn is that many things do not go as they plan. So they have the right to fail. So they find that whatever they planned didn't go as planned, or that the material they are using is not the material they planned. Sometimes the color that they envision is not the color that I was giving. Simple things has to be answered. But remember that at the end they have to perform. So problems arise, solutions arise. So you will find more possibilities, you will enhance your communication and more. Now, look at the end, it's an entire process. It's an intense 14 weeks, yes. But at the end, even though the phases of exhaustion, they are tired, it's a satisfaction. And one of the things that we collect over the last 4 years is the satisfaction comes from key important team skills that they develop. They feel that they contribute. So every time you go into a team, ask yourself, how much did I contribute for the success? How much did I interact with others? How much did I learn of it? Did I keep track of it? Did I put the best of it? And what are the knowledge, skills, and abilities that I developed to perform? Now, remember that all of that is based on agreement that you sign at the beginning of the semester. You ensure that all members are heard. You ensure that all workload is the same. And you ensure that if somebody's not performing, you will manage it. Can we fire the person? Of course you can fire the person. And that is something that we can deal on it. So make sure that somebody can be a lead, somebody is a technical lead, somebody take control of it. So all of that happened during this semester. Now, so is that the way that you assess? Look, one best way to assess a team is when you have a peer evaluation. So actually, I'm going to invite many of you. You can go and use this tool. It's open and now free for everyone. This tool I've been using with Dr. O'Neill during the last 4 years. He's from the psychology department at the University of Calgary. You can Google it, ITP metric system. ITP stands for individual team performance. So you will go into this system and you will evaluate your performance, but also the performance of your group. It will give you a comprehensive report and will help you to self-reflect on your work. So if you want to go and try, I invite you to go and try, because it will help you to reflect in 3 components. And now more than ever, if you are planning to work overseas, if you are planning to work in an engineering company, if you're planning to work in any environment at all, right now this is true. They will tell you how much commitment you have with you and others. They will help you to reflect about communications. They will reflect about your acknowledged skills and abilities that you can provide to a group. They ask you to reflect on the focus that you have, keeping track, work on your team. And they will ask you to reflect on your dimensions, emphasizing high standards that you use to work. Now, one of the basic interesting parts here, I invite you to pay attention into the pentagon here, is that the blue line will indicate the peer rating, indicates how others see you. And the yellow line is how you see yourself with respect to the peer performance. Now, most of the times we found that we underestimate few points. For example, the standards we underestimate, but people see you with high standards. Or sometimes we think that we are the best communicators and the peer rating is showing not. So it pushes you to reflect. So how the mark is assessment? Well, so at the end, your peers is giving to you a mark and assessment. Then you compile all the information in many different ways, and we give an open floor for you to express your creativity and innovation. Then you go back to your group and says, well, I'm going to be responsible, I'm going to be accountable, I'm going to be consultant, or I'm going to be informed based on all self-reflection that you've been provided. Telling, can we do all of this in 13 weeks? Yes, and it's been achievable. We have done it during the last 4 years, and it's been improved during the last 2 years. Now, after you reflect on your skills, you can go back to your group and says, you know what? I have technical skills and I have personal skills that can contribute to the success of the group. And then not other but you evaluate yourself. Am I good in long-term planning? I am good in writing communication. I am self-motivated. What did I need to improve my self-motivation? But you go back to your group and says, hey, this is what I have to contribute. And then you contribute in such that you plan, and then you reflect, and in the end, you will see how much work and how much learning happened over 12 weeks. Everything that you plan goes during construction. Yeah. If it's not working, some of the students go beyond and start going to the labs and testing materials to understand material behavior. They even improve in their houses, labs to understand. And one note, please, we do not ask students to go that beyond. We offer the opportunity to the students to be innovative, creative. These kind of things happen when professors are open to tell the students that it's okay to be wrong. Learn here, okay? Don't be afraid to be wrong. Why? Because when you try and you get prepared, over time, you will come up with something original. I'm going to show you some of the examples that we have in the previous years. So we start in a small lab with 12 groups, 80 students. Some people will be so creative that they will create their own t-shirts and logos. They will sell them later. And we had grouped up to have up to 150 students and be a big event at the faculty at the Department of Civil Engineering. Now, happy faces. As you can see, a lot of enthusiastic students at the end, big event. We have brought a lot of ideas and a lot of performances, definitely. But I asked the questions, is the main outcome those days to make happy students? Let me show you one thing, and I hope that I can do this. Teresa, please let me know if I can do this. So, oh. I'm not sure if I can do this now.
Yeah, let me know if I can help you.
I'm trying to share this one. So the question was, are we trying to make happy students? You can go into LinkedIn and see many reactions about over the past years, reactions of the students. Let me see if that goes. So the adrenaline in that day is definitely there because you need to demonstrate that whatever you plan, whatever you design, whatever you build, work. Sometimes it does, sometimes it doesn't. And how to overcome, how not to be afraid to be wrong. So again, are we here to make happy students? Definitely not. It's not about that. But I'm going to tell you that an example from last year is that one of this group of students took the task Be Young and they create a kit. When I said kit, is a demonstration and a scale down that a group of investors is looking right now to reproduce and be distributed in a high schools for students grade 0 to 9. So it's not about making happy students, it's about or feeling that you had accomplished and you can even create a business, right? Every semester is a different idea and more. We got attention so much this year that we have over 11,000 views. We've been asked on implement courses like this in another faculties and more. But I can tell you that students are not only smiling because they're happy, they feel that they are contributing, they feel that they learn, and they feel that they are growing skills up to the point that they feel ready in third year to put these in their portfolios to apply for internships or for summer jobs. Now they have opportunity to say that they had been part of engineering teams, that they produce something and they present these during the interviews, and the acceptance from industry is being really good. Now, plans for COVID time. Look, when I proposed this setup 4 years ago, the perception was that is not doable. Why the students have to go and learn online when we have professors here? Now more than ever, this dynamic is working. You can go work online. All we're looking is that you're gonna put all those skills, put it together into an idea, be creative and more. Now the lab portion definitely is still, we're working on that. And so far we're exploring to use Fusion 360 and maybe do the competition online. is still to be defined. Now, I know that is a lot of things, and sometimes even in the English, I use the Spanish pace. I will let you stop for a minute, Teresa, as I commented to you, and would like to open the floor for some questions before I continue with the second part.
Okay. So there are some questions. I can do them.
Yes.
Or you prefer to wait until the end?
No, let's answer a few of the questions.
Okay.
I mean, sharing a photo from the Rocky Mountains, you're more than welcome to visit.
Okay, so let's start. Maria Jose Quintero asks, teacher, thanks for your presentation. Here in Colombia, I have seen many teachers that want to change the way that they teach to improve our skills as students. Maybe I have realized that they have different problems because they take different strategies from other countries that have other social cultural skills. From your perspective as a teacher, which are the main steps that we have to do or review to improve it as an academic community?
That is a great question. That is a beautiful question. As I would say that one way to answer that question will be you get to know who is in your classroom. I would say that at the University of Calgary, we have 30% of international students. Come to the Faculty of Engineering, we have 30% of international students. So definitely you can implement all those strategies to different cultures and approach. So in terms of cultural condition, I would say that most of the techniques that I had shown you applies to all of them. Now, what you need to identify is that if the open-end question is more applicable to your community, if the open-end questions will look to solve local problems and more. The second part that is difficult to deal with is to come with new ideas and convince students, professors, and faculties. Because, as I mentioned at the beginning of class, it requires a lot of preparation. Sometimes you have to be ready and know what is going to be the outcome the first day of class. Sometimes we need to use teaching assistants. That means more money for the faculty. So what we need to look into the faculties is, are we willing to invest? Are we willing to change the dynamic that we had used in the past? And I'm going to show you later on with some of the slides that how you as a student can contribute to that change. Because we are not, as a students, we should not expect just that the solutions will come from the professors. I am fortunate enough to be exposed into the culture and engineering projects that I am bringing their experience to the classroom, but that is not easy. One of the difficulties I found, and to answer one a little bit more, is that we enthusiastically change one course, over instantly we change two courses for the same semester, and then we forget to is for the student.
I think we are losing you. I don't know if it's your connection or my connection, but we are losing you. We can't hear you. My team is telling me they don't hear you either. Maybe you're experiencing some connection problems of Jacqueline.
Creo que perdimos conexión.
Sí, yo creo que sí. Nos toca esperar. Lo sentimos por este inconveniente. Esperemos un momentito. You're back. We lost you for a couple of minutes.
Oh, it's too bad.
Okay, so we can hear you now, yeah.
Okay, so let's see if I can They connected this time. I'm not sure how much did you hear of the answer, but I was saying that enthusiastically, many of the professors, we tend to change and implement these new rules. The intention is good, but we forget to communicate within professors and we ended up overloading the students. Now, implementing new techniques from countries around the world, I can tell you that being exposed to so many parts of the world now, I can say that some of the techniques are applicable perfectly for different cultures and different environments. The faculties need to evaluate if they're willing to invest and so on. Now, any other question, Teresa?
Yeah, we have 3 more questions, okay? So the second one is from Camilo Andres. Do you think that COVID could be a benefit to work between universities? And how teamwork will evolve in the pandemic?
Okay, Camilo, I'm going to tell you one thing. Working as technical authoritation, I was working as what we used to call mobile worker. And that was seen as a high end. So what is a mobile worker? I was working sometimes from Peru, from Colombia. I used to travel all the way. And you were able to connect at any time from anywhere around the world. And the efficiency and results were still relevant. So yeah, I will say that it's been positive. Working with other parts of the world. I have an example actually today, I'm going to show you in a few minutes, that I am taking this opportunity to engage with universities like National University in Colombia. So right now we are working on a proposal where students from last year in civil engineering, I'm going to work with students last year in civil University of Calgary. So definitely is an opportunity. I will use what some people will say, COVID is giving us more opportunities. And probably what we need to be careful is that that the opportunities are not being closed only into a device. And at some point, we will need to interact, but definitely it will bring more opportunities of interaction, more opportunities of exchange ideas, and more opportunities even to communicate better.
Okay, so next question. David Steven Pinzon asks, for the development of projects in the group of students, would you think that it should be focused in the form of general knowledge of the career or social problems of its most direct environment?
Teresa, can you repeat it? Because that was a very complex, and I want to take a note of those things.
Okay, so I repeat it. For the development of projects in the group of students, would you think that it should be focused in the form of general knowledge of the career or social problems of its most direct environment?
Okay, David, that actually depends on the level of a course that you're talking about. So what I mean by that is the course that I just showed you, ENC 337, is a second year course that will develop more into general knowledge. I will tell you in a few minutes the same typical course that I designed for 4-year students that need to think about social implications and more outgoing interaction with the community. So depends of what level at the university you are. So we have so far 1st-year students with technical general skills, 2nd year with more technical skills, 4th, 5th year with more industry and community focus. So I will say that for your group work, think about in what year you are. If you are a 2nd year student, try to develop more technical skills and more soft skills that will build and be good evaluated at the end in your 5th year, when you're gonna have more background to reach out communities and industry.
Okay, so
Okay.
next question. Yeah, next question. And the last one. Juliana Nieto asks, how do flipped classrooms fit in the idea of empowering students?
Now, we have to be careful with flipping the class totally. When we flipped, and again, I have one more example to show you. When we flipped the class, we the class given the student to be creative, okay? We empower the students to take control of what they want to learn. When we do not encase the student is going to be wrong, you're going to fail, you're going to pass, rather than be creative, do the best, be the best performance, empowered to do your best, right? So when you flip the classroom, under my experience is, as an instructor, be careful, don't flip it totally. As a student, take control of what you want to learn and the tasks that are assigned to you. Take it not as a task assigned to you, take it as an opportunity for you to learn. So empower yourself to say, okay, this is a topic that apparently is part of my learning skills for these things. I have to do it. So nobody will empower you more than you. Okay.
Okay, I think these were all questions so far. If you want to, or if you would like to, you can keep on with the presentation.
Yes, we're gonna continue, and then we're gonna open it again for questions at the end. Look, what I want specifically for Juliana says is not to teach for what is the best or what is the worst. Right now, we're trying to accommodate the majority of the students and learning styles, right? So the point is not to teach each student in the way that he or she prefers, because it's not about preferences. It's about what do you feel engaged, encouraged, empowered to do. Rather, it is to make sure instructions is balanced and is not heavily biased in favor of one preference or its opposite. Okay. Now, I want to share this experience that recently just finished. That is the assessment as a great concern in the COVID time. So what is that? Well, in January, many of us got locked down and we were forced to move everything online, including assessment. And what we found is that in average per year, we were dealing with 20 cases of cheating during writing exams. And this winter, we ended up with more than 100 cases. So at the University of Calgary, we took care to tailor final exams that you can have access online, similar but different, because we wanted to have only space for the students to concentrate in the exam. But the exams were so similar that people start copying, and 100 cases and nightmare came. Cheating is being identified as a huge problem for us. And I believe, I'm not sure how it's in Colombia right now, because in my perception, cheating should be linked to ethical and professional behavior. We do one, or as a professor, I would say rather, I don't want to cut you as you're a cheater. We don't want to cut you as a cheater. We want you to tell you that you have the opportunity to behave as a professional. So be innovative, be creative, be authentic. So how we solve the problem? The university says, okay, let's go and find a proctoring software. And with the proctoring software, we are going to solve the problem. So many universities across Canada bought this proctoring software until we got an order to stop, because the Private Condition Act is following many students, and we were advised not to use. So the university decided not to use proctoring softwares anymore. So what to do? Well, let me tell you, it's not an answer so far about this. This is not a real answer yet. So this summer, without an answer, I'm being tasked to teach a summer course. And I said, well, I don't want promote students cheating. I don't want to expose the students to this. So why don't do something different? I'm going to give it to you a little bit of background of this course. This is a course that goes for 7 weeks and is very intense course, 8 to 10:30 a.m. plus tutorials. So we decided to live stream classes. We recorded them, we took notes, we uploaded. So if you are the ones who wanted to see videos, you're going to have access. For the tutorials, we create something that is called gate entrance. So for those who like to pre-watch pre-recorded lessons, you will have to come and be prepared to see a 30 minutes video. And after you will come, open the gate, get into the tutorial, and then you will be able to access the demonstration that we do live stream. And the third option was we did online quizzes, and the quizzes were supported by PDF quiz, specifically because of the technical conditions that we have. So what else we check here? We ask the students to, instead of tell them, okay, we know that you are cheating. We know. So, okay, do your cheat sheet and create a video for us. Okay, create a video for us, showing us what you have learned and how you plan to use that cheating process. Okay. Now, how was the final exam? The final exam, we ask you to create a report assignment, and then you have to come and do an oral presentation. What? Yes, oral presentation. Then you have to start participating. You have to be open to participate in many activities. So one of the tasks, and I want you to read this one, was to develop status concepts and create 2 problems on a 3D4 systems. And we give you a client. We said that the engineering faculty at the University of Calgary is looking to create a reserved blank data of problems demonstrations that can be used during the lectures with the future static students. So we're giving to you a task to be creative. And also we're giving to you a client that are students and professors. So then you have to perform. The 3D4 system problems are to be developed based on the scavenger hunt. So you need to go outside and start observing, okay? And create a key answers by hand, and also using Excel computer applications is the best. How was the final exam? The professor will assess you during 7 minutes about your final project, and then you jump into with my teaching assistants, and we're gonna ask you 2 specific questions about content of the course. So you have to be prepared. You can use everything you want. You can use your cheat sheets. All you have to develop is skills and communication, technical concepts. We create a cluster questions. So, oh, Jacqueline, but after you have the order presentation, they can text and they will know what are the questions. Look, we create 28 cluster questions groups. So the questions, all of them were different. We provide in advance the rubric, and we want the students to know that we want you to improve your verbal communication. Which one? The technical one. The technical using static terms. The accuracy with some of them, were you be able to provide us correct answers or not? And we wanted to see the ability to elaborate answers, right? Can you elaborate answers from a complex, simple to complex question? So the following are examples that we just finished last week. So this is from the students, and please notice that this is a second year students who decided to take a very intense course during the summer. This student went out and started observing. So one of the first tasks is go and observe how the structural system in your city, in your house, in your kitchen are behaving and linked it to the concepts that you have. Then he is in a farm. So actually he is driving from here. He is 8 hours far from the university and he is living in a farm. So he told us that he started, after the 4th week, he started observing not only outside, but into his farm. And then he created examples, of problems that can be used in the future using simple observations from his farm. Now, he provided the students a plan to solve the problem. So he says, what is the first thing? Draw a free body diagram. Do not forget to use equilibrium equations and use a matrix works in Excel. And one interesting thing here is that he was reflecting in his work. He was saying, using the coordinate listed previous slide, we're able to find the unit vector. So he explained in a clearly manner to his clients in the future, second-year students. Then he says that we can use concepts of dot product, cross product to find the solution. And then he says that here you have many options to solve the problem. And then he shows which one is them. Now notice, and I highlight this one because this is what I wanted to see in future engineering students. This is a second-year student thinking like an engineer already. As a future engineers, we know the value of time. Yes, time is the only thing that is valuable in those days. And for that reason, we solved these equilibrium equations with tools that we have available, like a Microsoft Excel. So then it shows, I create a tool for the students in the future how to solve this problem. That is a fantastic example. Then he kept going. We asked only for 2 problems. And he says that he started observing that every single item in his farm, in his house, involves statics concepts. And he started drawing, he started, I'm not saying that is right. I'm not saying that that is the right approach, actually. Maybe he's wrong, but he is forcing himself, he's empowered himself to connect the concepts from a lecture into real examples into daily life. Now, let me see, I want to share with you this one. Teresa, can you please let me know if you see the face of this guy? Yes?
Yes, I see the face.
Okay.
Yeah.
This is an example of one of the assessment items in this class. So we asked the students to record their cheat sheet and what they're going to use. We did not give parameters. They can just take a piece of paper, do whatever, or just let us know what they did. And I want you to pay attention on the items that he expressed there. Let's see.
This is a video from my engineering scavenger journal. I've been keeping in line, we're using OneNote here. So start out, that's Santiago Calatrava. I went to Wikipedia for a quick bio, and then I went to his website to get some of his pictures and see what he had. This is one of his first projects, completed in 1985. So humble beginnings, but gone on to complete very amazing things. So you can really see how statics plays a part, because there's a lot of forces to balance, especially when you're only using one beam to one single column to support this entire bridge. So pretty neat. The Peace Bridge here in Calgary. So Alexander Calder. Again, we have some Wikipedia page just to recognize the bio. And some examples of his work here. And you can see how statics are really playable in this, because, you know, it's really hard for them to be this well balanced without having to have a mortar to spin them and spin it in the air. So I think that's pretty neat, actually. So for a week one entry, I didn't really do a lot of calculations. I was just trying to estimate some heights and stuff and see what the moments would be. So I know that we'll be using the transmissibility of this one. We have external forces acting on it, which is much like the example we had in class of the light post. I wasn't really I didn't have any digital copies of that yet. So I'm trying to draw some free body diagrams here of this and how the first couple is going to be acting on here. And I took an approximate measurement on that. So my free body diagram for the host itself. Week 2, I said I've bitten off a bit more than I can chew, to be honest. I have this motorcycle lift in my garage because I'm restoring this motorcycle, and I wondered about what the force on this piston would be here. So I looked up the weight of the motorcycle, it was approximately 310 pounds. Took some pictures of the members. I'm using this example from the notes because this shows the center of gravity of the bike, well, and how it breaks up the normal force acting at A and B here. I was able to follow the example and get a answer for each of these. And then I also noticed that these pins would be free rolling, so the forces will act on them in this manner because they are free to turn. I checked. So I came up with this free body diagram, and I'm missing some things I have to add because every time I try and do more with it, I realize what I'm missing. I don't have this measurement from the center to here. Maybe we can assume that that's 9 inches. So I'm beginning to calculate the resultant forces going down here. I'm having a little trouble getting started with it. I calculated the moment at B, but I don't really know. That doesn't really tell me very much other than, there is a lot more force acting at this overhang in this kind of fashion. Or actually, sorry, this, because that's positive. So far it's been very challenging, but I'm sure I can get something on this. So some of the other things I have in here. Not this one. Handy formulas for the force pairs, and just reminders myself how the unit vector works and how to do that. Here are the unit conversions that I've taken from the book. I've put them here so they're just a little bit quicker for me to find. And some action forces here in 3D on the left and 2D on the right. So I have these for easy reference. And for problems from class, I haven't really been able to do it digitally because we're doing it in Zoom. But what I have been doing is taking snips from the lectures and printing them out in chronological order here. So I have them all in order as we did them for class, so it's easy for me to find in that respect, along with my notes. Some handy things about cross product. More examples. So far it's been working actually very good. I can tutorials are in here too for quick reference. And yeah. So I'm able to grab these examples from class, and so far it's worked fairly good like that.
Okay, so I want you to get that students are now given a real guidelines of what they have to put into their cheat sheets. What we said is you can use whatever you want for your quizzes, for your oral presentation. Some students, as this student, Ken, his name is Ken House, did a very good job. Of course, we have students who just write down a paper and they do, of course, but I can tell you that out of 53 students, more than 60% were totally engaged, and most of the videos were entertaining like this one. They showed that they were engaged. They wanted to connect the concepts from class to the real condition. Let me show you this one with the students in the front. One of the concepts that we develop in this class is how the forces travel into a floor system. So apparently this student had the opportunity to build his own structure. Most of the materials that we use here is wood. And then the student decided to start building and connecting to everything that he saw in class. Some of the concepts that are using are not necessarily right, when he says he's a Zero Force member. So we were discussing that during the oral presentation. So they sent the final report 4 days in advance. So then me as a professor review all of them. They come and I start questioning and discussing over several minutes what they learned and how connect the concepts. It was fun to see that this student, every time he was doing anything, was connecting to his class and how he put together even concepts like how to transfer the load into the system, right? How to provide lateral support to the beams, to select the section that was best suitable for the construction, and being able to see that there's some basic concepts. So basic concepts can be applicable to anything that you do, even estimate the cost. At some point he says that he could save a little bit of money. And again, happy student, I'm not sure. I don't like to use happy word as a description for these students. Can you embrace, can you empower yourself to say, not the professor, to say yourself, because that is the self-reflection portion. Can you reflect to say, hey, this is what is the learning outcome. This is what I'm supposed to learn. Can I do it? You pass the exam? Yes, you pass the exam. If you didn't, it doesn't mean that you didn't, because it's not exams, right? It's an oral exam. Things to consider for the courses, right? Definitely the number of credits. So people thought that for 3 credits was a lot of work, and I tend to agree with that part. Yes. And maybe you need to limit the number of activities because the remote access. I found that some of the students do not have computer or they are sharing computer with their families and so on. Technology issues, as we just experiencing right now when the internet kick us out. Try to serve all the learning styles. So we did individual work, but we did group work. And sometimes we need to evaluate a little bit more into this one. Front professor perspective, more time preparation, definitely. And we have only 1 TA, so it was short for 60 students. So we are saying that probably this is not the best approach for this fall semester when we're gonna have 800 students. So next semester, we are dealing with 800 students taking statics. And we cannot find the answer, how will be the best way to assess. Definitely, we're gonna implement some of these techniques with the students. And right now we are hiring approximately 21 TAs to support the students. So we're gonna have 21 TAs supporting the students in addition to 5 professors. So all of that, you've been listening for almost 2 hours now, and I'm gonna make it short right now, is when you may say, well, I'm a student. Why should I care about design courses? Why should I care about those things? Actually, you should care. My insight here is that you should become more active participant in the development in your faculty and your courses, providing good peer review feedback to your professor. It's not about complaining. It's not about saying what is wrong. Actually, it's providing us enough data to create the best suitable material for you to develop the basic skills for you to succeed in the future. So here in Canada, and I believe you can Google it, and some of you who wants to get involved can make it use of it. So we use the National Survey of Students' Engagement, right? So we do a retreat with the students every 3 years. So we bring the students from first year, second year, third year. And we provide a survey that has 47 core questions, right? That takes approximately 15 minutes, is voluntary. And the questions are, for example, during the school year, how often have you done the following? Ask questions or contribute to course discussion. Well, this is student said often. And you prepare 2 drafts or more of an assignment before turning in, very often, yes or not? Hard to believe. Come to class without completing reading of assignments? Never. Now, one of the things that we wanted to get more accuracy information is when we make it voluntary. So you voluntarily fill it out. So what we found in 2017, fortunately this year we haven't been able to do one retreat this year, is that 28% of our students, so as I said, we are 800 students first year, respond to the survey. And on the 4th year, 41% of the students fill out the survey. That is a good number, by the way. What we wanted to check in this survey is ask students about their experience in these project-based flipped classrooms and more, how they spend their time at the university, online and more right now, what they gain from the attendance, the interactions, peers, faculty, and others. It helped us to design better courses and bring you a better experience. So we had identified 6 areas to be highlighted. 6 ones: teamwork, undergrad research, supporting environment, reflective learning, real world applications, and students. I'm going to share this with you with the only purpose that you will get engaged and enthusiastic. You will empower yourself to be participative in surveys like this in your university. The University of Calgary, and when we said SSE means Schulich School of Engineering, scored higher than the University of Calgary in general, and we've been good since 2014. Please notice that we are paying attention to this attribute as is a requirement to get accredited programs. We are implementing peer reviews as the Dr. O'Neill, as I shown you, and we are doing reflecting activities as I commented to you. Reflective learning, and probably one of the questions that you may have is, Jacqueline, do you see the product the students printed out? Do they really know what they learned? So we're working on that part to that at the end of the course, the students will say, oh, this is the skills I improve. This is what I am good at right now after this class, right? One of the things that I'm working in one of the classes is that the students at the end of the class will create a portfolio in such that they can present it during the interviews for summer job applications or for internships. We are creating an environment for the students to do undergrad research. So we're getting some money from the government, where we invite more faculty members to hire students during the summer and help in their research environment. So we are improving for the first year students, definitely. The 4th year, still we're improving numbers there. Real world applications. Well, that was something that was a surprise, actually being from civil, right? Students asked to do more case studies in engineering, and students ask for more problems project-based learning, aims to open-ended and authentic solutions. And how we manage this? Well, this is very important that the universities looked into supporting environments. Yeah. You consider variables like diversity and intersectionality. You check involvement, peer interactions, and faculty contact. So we're trying to work on those concepts. Now, student workload. Well, if most of you are engineers, so you will know that most of the times we score higher. Doesn't mean that that is better. The University of Calgary right now, we score 4 hours more per week than in average student, right? So what does linked to it? So psychological distress. So right now we have implemented mental health awareness program for some of the students. The perception of the workload highly correlated with motivation, and we need to change the perception to the students and instructors to develop better courses. Now, I'm not sure, Teresa, how I'm doing with time, because
you're doing fine. I mean, you have still time to keep talking or.
So we're going to stop in a few minutes.
Okay.
With the audience today, last implementation that I've been working with in the last 4 years. is that a project-based courses are important because they apply traditional classroom knowledge, right, of what is learned, and hopefully apply to the real work. So I just connecting this one to a Juliana question before. And David's question is, what is the level of application and engagement of the students to the real work programs? So what is 570 for us? It's a final year project base, and students collaborate with 5 or 6 members, and the students will use the design process that they had gained from first year, second year, and third year, and they will use the technical tools they develop over the years learning at the university. The students are encouraged to do site visits, community consultations, and a great incentive for the students to engage with industry partners and wider the community. So this is when I linked it to some of the questions. Right now, it's hard for us to do site visits, but it still is possible to reach out communities and actually overseas. And this year, we're working to partner with the National University with Dr. Kaori Takeuchi to work with a project with students in Colombia and in Canada. And we are aimed to present the final outcome into a design fair. So previous years, we engage community, we invite engineers from the community to participate and evaluate the students' work. To tell you that we had come with people who are investors, they see innovative ideas, they hire students. Sometimes they come and invest or provide money to the students and more. So we're trying to do the same thing online this year, but we're trying to aim for the same results. Now, students participate all across all disciplines. So civils versus mechanical versus electrical versus petroleum and more, right? Now, who is involved? Professors, definitely professors are going to provide it to you support. And in many different areas, environmental, project management, transportation, whatever you decided. I just showing an example into the civil program. We partner with industries. So the university reach out, community reach out, people who need support from the students and faculty. It's a cheap labor, definitely, and seen an opportunity. And we start working together. Example of this. The city of Calgary, which is the government office for the Calgary city, approached us for a concept design to be developed by students in consultation with the community for a building to build and replace an existing pedestrian bridge that is located at the southwest area of the city. Look, so we engage community, we did a survey, we did a possible partner or industry partner, we involved the students, and we asked the students to come up with a concept design. The students came up with this design that the city of Calgary right now is using as a start point or line base of the project. It was presented to the entire community, and right now they're evaluating the material or the type of materials and environment and location of the pedestrian bridge. So this is the add value and implementation of these kind of projects that a 5th year or 4th year students can do with the community and industry partnership. Yeah? So I invite you to go out, look for opportunities, and go back to your professors and say, hey, this is what is needed. Can we find the solution? Can we find someone to provide us support to invest in us? Examples, not only all the projects are oriented to the community and more. Example, a year ago, it's 2 years ago actually, we developed an engineering teaching tool for teachers from kindergarten to grade 9. So we create a teaching kit tool. We print out 12 and we distribute it across the city. And we use one of the kits now, one of these tools kits, as a summer camp demonstration for the students who come to the university. So go and explore and get ideas. Now, you want to participate in this class? Well, definitely you have to do course outline modules. So when we proposed this once again, we were told that online modules were not relevant. It's too much work for the students and so on. But what we found is that students come and take these modules and they create a baseline for all the students to understand what is, for example, a project management tool like RASI chart, like a breakdown structure. And they give you conditions for everyone to complete basic knowledge needed to start any project. Now, modules are very simple. You have a complete quiz at the end. Jacqueline, but the quiz, did you fail the quiz, whatever. If you fail the quiz, the software will bring you back to the slides, and then you have to go back and re-review. The purpose is not to make you fail. The purpose is that you pass the quiz and you learned what the quiz is, what the module is about. So if you fail the quiz one time, they will bring you back, review. Did you pass? If you fail the second time, go back and review until you manage to pass it. To pass and learn. So the intention is that you learn. This is a very intense course, so it requires many deadlines. So it push and test your abilities to meet deadlines, to work in teams, to communicate. It push the ability to reflect and to compile all the skills that you accumulate over the years. It pushed to evaluate your students, to evaluate yourself. And in this time, on the 4th year, you do it 3 times. And you come to a seminars and then you learn how to provide feedback, how to receive feedback, how to act, how not to react, what kind of language you should use when you provide peer evaluations, and how to create a solution for problems. We bring people that help you to think as an entrepreneur. Think about that you always want to sell your ideas. You are providing solutions to a problem, but at the same time, you are selling your skills or you are selling the solution that you have in your problem, right? We bring people to help you to build the skills in conflict resolution, and definitely now more than ever, stress management and mental health awareness is part of it, okay? Now, in previous years, we used to have more than 1,000 people visiting the fair. And COVID times, well, right now we're thinking in strategies how to do it online. Like even presidential campaigns can be done online. So we're gonna try to mimic something like this. So why not? Now, examples of applications. These are very close to my heart because this is at the Northwest Territories, close to the North Pole, if you want to call it. And okay, thank you, Teresa. It's almost done.
Okay, perfect.
In this case, we got 25,000 support from the government. The ideas drafted by students are implemented and used right now by the city of Northwest Territories. Same thing here, ideas for the green tunneling project that we're working to have a tunnel project. So the students were heard by the city of Calgary. They were provided with a lot of insights and a good feedback. Now more than ever, and that is probably gonna conclude with, empower yourself to be part of your courses, to provide a good insight to your professors. Learn to provide feedback, not to complain, and to improve what is needed for your skills. Make sure that you can mention some of these skills that are needed more than ever into your engineering course. Discuss with your professors, discuss with the new techniques, and make sure that you are active participant. Active participant into the surveys that the faculty gives you, and actually active participant to professors. Let me tell you that many of the courses that I show you are being done thanks to students that I hired during the summer, and they helped me to draft all these ideas. And probably I'm just gonna close with this probably insights that I have, that teaching engineering should be supported by research learning-based techniques. So everything that we implemented can be worked in any environment with good support from the faculties, definitely. Technical knowledge is important, but teamwork, ethics, accountability, respect, and resilience are fundamental in any engineering work, now more than ever. Learning by doing, yes, and is demonstrated. The lecturing not always inspire or engage, but it's still relevant. So we need to balance lecturing and doing. Engineers that want to teach need faculty support to develop and redesign courses to fit new global necessities, definitely. But please, we should not forget that if we flipped all the courses, if we do all project-based course design, the students will be overwhelmed, and actually it's been demonstrated that it's not effective. We should practice the review, reflect, and implement as a part of the engineering course, as a part of a student participant, as a part of engineering life. How can we improve? Well, self-reflection. Do we improve our communication? I'm motivated interest in the course content. How can I motivate myself? Do I need motivation? Do I need a teacher to tell me that you're gonna get a 0 to go to class? Or I just can go because I really want to learn? Can I broaden and deepen understanding the course content? Can I improve my critical thinking skills? Can I improve my critical thinking skill? So, Teresa, I hope that this, I think, went a little bit over to what I planned, but I'm not sure we're gonna have time for a few more questions. But I just wanna say thank you for the opportunity to share this.
Thank you, Prof. Jacqueline. We have time for one more question if you would like to. So I'm going to formulate a question. It's from Maria Jose Quintero. I have to certain that this is the great opportunity to connect with other universities and share different tools and strategies. How can we contribute to create those connections as a student to don't let this task only for the teacher?
That is a beautiful question.
Yeah, very helpful question, right?
Okay, one of the ways I would say is, I'm gonna answer with the example that I'm doing right now with the university, with Professor Akaori. We came up with the idea, ask the students to reach the professor. So the professor connected to Professor Akaori, Kaori connected to me, the professor to professor, and in a few weeks we plan to connect. If you have an idea that you think that in somewhere around the world, anyone that can help you, go contact your professor, establish the contact, and it's easier for me to answer a question, okay, that it comes from your professor. I'm pretty sure many people around the world are going to be open more than ever now to contact. So that is a good way. Sometimes I have received emails from different parts of the world. You can try to do it yourself and then trying to contact the university. Individual basis is harder, but if you engage your community university, it will be a lot better and it's easy to be heard from other universities.
Muchas gracias, profe. Yo te voy a despedir en español. Vamos a cambiar la lengua de la charla, si te parece bien. Pues te quiero agradecer en nombre de la universidad, de la Facultad de Ingeniería, de la Facultad de Minas, pues que hayas estado aquí también queremos agradecer a la profe Kaori por habernos facilitado tu contacto, pues porque sin ella no hubiese sido posible tu presencia aquí. Esperamos que esto sea como el principio de una colaboración. Creo que es mi despedida con todos los participantes de la cátedra, pero es que esta virtualidad nos está llevando a contactar con más expertos que pues a lo mejor en un modo presencial no hubiésemos tenido la oportunidad. Entonces, pues repito, espero que sea como el principio de una colaboración con la Universidad Nacional. De nuevo, pues agradecerte tu tiempo, tus enseñanzas. Súper interesante la charla. Muchas gracias, profe. Y bueno, a los demás, entonces, bueno, espero que se queden acá porque ahora pues tenemos la clausura de la cátedra de manos de las decanas.
Primero, muchas gracias. Estoy súper feliz de haber vuelto a mi alma mater. Adórenla,
Qué bueno.
llévenla alto por siempre. Te agradezco.
Qué bueno. Nos alegramos de eso y sobre todo nos alegramos de que egresados de la universidad pues siempre quieran colaborar con nosotros y los podamos tener en cuenta para este tipo de actividades. Muchas gracias, profe.
Un abrazo para todos.
Otro para usted. Entonces, bueno, vamos a dar la bienvenida a la decana Verónica Botero, de la Facultad de Minas, y a la decana María Alejandra, de la Facultad de Ingeniería. ¿Cómo están? Pues a todos, como sabéis, ya llegamos al final de la cátedra. Como les dije al principio, los voy a echar de menos después de estas 2 semanas, pero pues ya hablé mucho durante estas 2 semanas, así que pues le cedo la palabra a las decanas.
Hola Teresa, pues muy contenta de estar aquí en la clausura. No sé si Alejandra quiere hablar primero o si hablo yo, ¿cómo hacemos?
Adelante, profesora Verónica.
Muchas gracias. Bueno, yo solo tengo unas pocas palabras. Hoy ha sido un día muy largo. Ustedes saben que la consulta para decanos se extendió. Estamos en consejo académico que todavía no se ha acabado. Entonces estamos como en varios sitios a la vez. Yo simplemente les quería, pues primero que todo, saludarlos. Muy buenas tardes a todos los asistentes a la Cátedra Internacional de Ingeniería 2020 y decirles unas poquitas palabras de lo que creo que pasó aquí durante estas 2 semanas. Durante 11 días hemos tenido la oportunidad de asistir y escuchar expositores de las más altas calidades académicas y humanas. En esta cátedra se han abordado una cantidad de temas que tratan de relacionar la ingeniería con el coronavirus y los efectos que esto ha producido en la sociedad. Esta variedad de temas nos ha permitido reflexionar acerca de tópicos tan disímiles y variados como mercadotecnia y cambios en los hábitos de consumo, inteligencia artificial, transformación digital, blockchain, movilidad humana, rastreo, redes sociales, fenómenos de contagio. Hemos hablado de santuarios agroalimentarios, de desafíos en la construcción, oportunidades de investigación como las que nos presentaron desde México el viceministro del Ministerio de Ciencias. Hemos hablado de innovación disruptiva, de desafíos educativos, de educación remota, telemedicina, laboratorios virtuales e inclusión educativa. Y nos han acompañado expositores de muchos países. Yo creo que esto es uno de los del carácter más importante que tiene la cátedra, pues de las cosas más interesantes que tiene. Hemos tenido expertos de Alemania, Argentina, Canadá, Costa Rica, Colombia, Cuba, Estados Unidos, Honduras, México, Perú. Hoy de la Universidad de Calgary, por ejemplo. Y han podido participar estudiantes tanto de la Facultad de Ingeniería de la sede de Bogotá como de la Facultad de Minas de la sede de Medellín, pero también se han podido conectar egresados de la universidad, personas externas. Entonces, es decir, estamos haciendo un ejercicio académico que nos permite demostrar que la pandemia destapó grandes desigualdades y problemas estructurales del país y del mundo, pero también nos ha permitido idear nuevas formas y herramientas para mantener nuestras relaciones vivas y poder proponer ejercicios interfacultades con actores internacionales que enriquecen nuestras aulas. Este es como el compendio de esa posibilidad que nos dio la pandemia. Entonces hoy podemos reiterar satisfechos que la Universidad Nacional de Colombia es verdaderamente nacional, porque puede llegar mediante herramientas TIC a todos los rincones del país, pero también nos está obligando entonces a modernizar nuestros sistemas de información académica de manera que nuestros programas académicos puedan realmente compartir recursos y contenidos. Esto nos va a obligar a los decanos que ocupemos los cargos pues de aquí en adelante, que realmente repensemos cómo nos conectamos. A todos los conferencistas, a los asistentes, a la decana de la Facultad de Ingeniería, María Alejandra Guzmán, a su equipo directivo y sobre todo al equipo del Programa de Relaciones Internacionales PRI, que en cabeza de Teresa Mido, Mil y mil gracias. Esperemos que esta cátedra no sea un ejercicio aislado, sino un escalón más en ese ideal de construir una universidad basada en la cooperación, la complementariedad, que no se nos puede olvidar, y la integración. Muchísimas gracias de verdad por este esfuerzo de estas 2 semanas y espero que lo hayan disfrutado bastante. Muchísimas gracias.
Gracias, profesora Verónica. Me uno a tus palabras. Yo quisiera agradecer a todos nuestros invitados, nuestros conferencistas nacionales e internacionales que nos acompañaron durante estas 2 semanas con sus charlas muy interesantes. Estuve en varias de ellas, temas absolutamente pertinentes y en los cuales todos los muchachos inscritos mostraron interés. A todos los chicos de la Facultad de Ingeniería de la sede de Bogotá, de la Facultad de Minas sede de Medellín que se inscribieron, hicieron un esfuerzo muy grande porque sabemos que estaban agotados, el semestre recién había terminado y hicieron un esfuerzo muy importante por asistir a la Cátedra Internacional de Ingeniería, lo cual nos permitió mantener viva la figura de la Cátedra Internacional en medio de las adversidades. Pues muchas gracias y les espero que haya sido una experiencia muy enriquecedora. Y efectivamente, como le dicen la profesora Verónica y María Teresa, que sea el principio de unas relaciones duraderas y estrechas de colaboración con todos nuestros invitados y con la Facultad de Minas de aquí en adelante. Gracias a todos y que descansen este fin de semana.
Muchas gracias, decanas. Pues, si me permiten, yo quería agradecer no sé si activé mi cámara. No, perdón, qué pena. Si me permiten, yo quería agradecer a mi equipo. Ustedes nos agradecieron a nosotros, pero pues sin Juan Sebastián, sin Sara, sin Juan David y sin Paola esto no hubiese sido posible. Y lógicamente, pues sin el apoyo de la Facultad de Minas y sin el apoyo de la Facultad de Ingeniería. Así que muchas gracias a ustedes también y espero, pues como ya dijeron, que esto sea como el principio, pues de fortalecer relaciones con todos los expertos que invitamos y aparte de eso, pues que si sigue esta pandemia, pues que podamos seguir ofreciendo a los estudiantes espacios como este. Y pues muchas gracias a todos los que han estado ahí. Y yo creo que si les parece bien podemos dar entonces por concluida esta Cátedra Internacional de Ingeniería número 14, pero la primera que fue virtual.
Un aplauso.
Un aplauso para el equipo.
Y a todos los que apoyaron, de verdad. Y bueno, nada, feliz fin de semana, a disfrutar de la cuarentena y el toque de queda. y de los bares sin alcohol.
Gracias.
Gracias, que estén todos muy bien.
Hasta luego. Feliz fin de semana.
Gracias.